Welcome back, class, into video part B for the binomial expansion theorem. Remember, we are taking this 2x plus y to the third power. And what we've done so far is we looked over at Pascal's triangle at the third row, which was 1, 3, 3, and 1. We spaced those numbers out, 1, 3, 3, and 1. And then after each digit, I took the a term, which we said was 2x, and I put that in parentheses after each of those numbers, after each 1, 3, 3, and 1. And then I did the same thing with the y. Right after the 2x, I put a y in each spot. And then, because I was taking this to the third power, I put my first thing in parentheses, right here, this 2x to the third power, and then the y that's going with it to the 0th power. And then the next one, I did to the second and to the first, and then the first and second, and then to the 0th and to the third. Basically, I sent 1 over every time. So it started out at 3 to 0, and the next time I sent 1 over from the 3 to make it 2, 1, and then 1, 2, and then 0, 3. So, from here, we are just going to basically simplify this. This right here is one term. And so it's going to be 1 times, simplifying this here, I would have 2 to the third, x to the third, y to the 0th power. My next one would be 3 times, we'll need the parentheses there, 3 times 2 squared, x squared, y to the first power. There would be 3 times 2 to the first power times x to the first power times y squared. And then my last one is going to be 1 times 2 to the 0th, x to the 0th, y to the third. And now I'm just going to go through and simplify this. 2 to the third is 8, and y to the 0th power, remember, anything to the 0th power is just 1. So this whole term right here ends up just becoming 1 times 2 to the third is 1 times 8, which is just going to be 8x to the third, plus 3 times 2 squared. 2 squared is 4, so 3 times 4 is not 4. 3 times 4 is 12, x squared y. My next one will be 6xy squared. And then my last one here, remember, 2 to the 0th power is just going to be 1, as is x to the 0th. So I just end up with a whole bunch of 1s times y to the third, which would just be y to the third. This right here is my answer. That is the correct expansion of 2x plus y taken to the third power. If we were to do that the long way, write it out, 2x plus y times 2x plus y times 2x plus y, this is what we should end up getting. Let's try with a negative. This does get a little bit more interesting, a little bit more challenging. It is being taken to the fourth power, right? So we're going to head over to Pascal's triangle, and here is our fourth row. Remember, the first one starts at 0, so 1, 2, 3, 4, which would be 1, 4, 6, 4, and 1. We go back over here. I'm going to space those numbers out. I said it was 1, 4, 6, 4, and 1. Now, after each of those numbers, after 1 and after 4 and after 6 and so on, I'm going to put 3 in parentheses. That's my a term. And then I'm also going to put negative x in parentheses. That's my b term. The next thing I'm going to do is start applying exponents to those things I just drew in, that a term and that b term. So I'm taking it to the fourth power. So the first one, the first 3 that I wrote is going to be taken to the fourth power, and it's the thing that it's being multiplied with is going to be taken to the 0th power. My next term would be to the third and to the first. Remember, I'm basically sending one over. Next one would be to the second and to the second, and then to the first and third, and then 0 and 4th. What you'll notice is that every time you'll start with whatever the exponent is that we're taking it to. Like this time we said to the 4th. And then 0, and it should end with the opposite of that. 0 and to the 4th. Now we're just going to go ahead and start simplifying. So here, my first term, then I would work on simplifying. I would just have 1 times 3 to the 4th times 1, right? Because anything to the 0th power is 1. 1 times 3 to the 4th times 1 is just going to be 81. Fun stuff. My next term, I'll have 4 times 3 to the 3rd times negative x. Well, because I have a negative here, my whole term is going to be negative, which means I'm going to end up subtracting. And then I'll do 4 times 3 to the 3rd power. And 4 times 3 to the 3rd is 108. So it'll be minus 108x. My next term will be 6 times 3 squared is 9. In negative x times negative x will just be positive x squared. So my whole term will be plus 54x squared. Now I'll move on to my fourth term, which would be 4 times 3 and negative x cubed is just negative x cubed. So I'd end up with, right, I've got a negative there, so it'd be minus 12x cubed. And then my final term, 1 times anything to the 0th is 1. Negative x to the 4th, I'm taking it to a positive power, so it's going to end up being positive, right? Negative x times negative x would be x squared. Times another negative x would be negative x cubed. Times another negative would be positive x to the 4th. So my last term will be plus x to the 4th. And there I have my answer. This is my expanded binomial, right? It's like taking 3 minus x and multiplying it by itself 4 times. One thing that you'll notice is anytime we are subtracting, like we were in this problem, we had 3 minus x to the 4th, we are going to have an every other pattern when it comes to our positives and negatives. Our first term was positive, and then negative, right? This one is positive, this one's negative, positive, negative, and then positive. That'll always be the case if we have, in our binomial, we are subtracting. We got a couple more. Let's do one more. Let's just do this one here. 2x plus y to the 5th power. Now once again, we're going to go to Pascal's triangle and pull the numbers from the 5th row, which is 1, 5, 10, 10, 5, 1. And I'm going to write those numbers and space them out. 1, 5, 10, 10, 5, 1. Then I'm going to go to the first term, which is 2x, and I'm going to write that after each of these numbers I've written, after each of these essentially coefficients. 2x, I'm going to put it in parentheses each time. 2x, 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 and 2x. My b term is y. I'm going to put that in parentheses right after it. Y, y, right, so on and so forth. And then the exponent pattern, it's to the 5th power, so it'll be to the 5th into the 0th, to the 4th into the 1st. 3, 2, 2, 3, 1, 4, 0, 5. And then I just work on simplifying. Oops, too far. The fun part. All right. 1 times 2 to the 5th times x to the 5th times anything to the 0th is 1. 2 to the 5th is 32, so this whole term will be 32 x to the 5th. My next one, I have 5 times 2 to the 4th x to the 4th y. Now 2 to the 4th is 16 times 5 is going to be 80, so this whole term will be a positive 80 x to the 4th y. Next term, 10 times 2 to the 3rd x to the 3rd y squared, right? I'm taking that to the 3rd power and I'm applying it to everything in the parentheses. 2 to the 3rd is 8, so this whole thing will be another 80. This time it will be x cubed and y squared. That's 1, 5, 10. My next 10 here will be 10 times 2 squared x squared y cubed. So this term will be plus 40 x squared y cubed. I'm running out of room here. We'll see if we can find a spot for it. Our next one will be 5 times 2x y to the 4th. So our next one will be 10x y to the 4th. And our last term, 2x to the 0th power is just going to be 1. So I have 1 times y to the 5th. The whole expansion is right there. So that's the binomial expansion theorem. You guys will have some homework, some problems like this in your homework. Good luck out there.